Okay, so 3-1, your first note was a graph that is made up of connected lines or curves. That is a continuous graph, right? The word is in the definition, continuous graph. So when you see a graph and you have like a line where the points are connected, that is a continuous graph. The other type of graph is made up of distinct unconnected points, which is a discrete graph. And we'll talk about different situations where you'd have continuous or discrete. So a discrete graph is just going to be random wherever the points are. So some graphs will need to be continuous, like rainfall, right? It changes as the hours go on and how much rain you got. Or maybe you are buying or selling something or people, you wouldn't have parts, which would be discrete. So we're going to talk about different situations where you'd have a continuous graph and a discrete graph, okay? So in these graphs, you're going to have input and output, domain and range of each value, okay? So the set of the first coordinate of a relation or function, all your x values are called your domain. Oops. And those are your input values, also known as your x values. So if I had the ordered pairs 1, 2, 3, 4, and 5, 6, which of those numbers are input values, x values?
3 and 4.
3 is an input. In my ordered pairs, 1, 2,
1, 3, 5.
1, 3, and 5. Very good.
So then the other ones are your output.
Yep. So the other ones are called range, or otherwise known as output. Okay, they're the y values. So in that same example, what's my set of my range?
2, 4, and 6.
2, 4, 6. So it's that whole set of numbers, not just 1 or 2. It's all of them that are your input, all of them that are your output. It's a set of all second coordinates. Okay? So now we're just going to talk about reading graphs and when we would use continuous or discrete and then finding domain and range from those graphs. Pretty simple lesson. Okay? So interpreting graphs. Jack took a drive in the country. He drove for a while, then stopped to buy gas. He drove a bit more and stopped at the roadside fruit stand. After more driving, he stopped for lunch. Then he drove straight home. Which part of the graph represents these events? So, where he stopped at a roadside fruit stand, where is that shown on the graph? Where does it show that he stopped?
F.
He stopped for gas, though, first. So B would be the stop for gas, right?
Yeah.
Then he stopped at the fruit stand next. So when on the graph does he stop again?
D.
So D is going to represent the stop at the fruit stand, right? So we have time going on, but the distance, you can tell he's not driving, right? He's not getting any further from home, but the time is still going on. Does that make sense looking at that graph?
Yeah.
Okay, so we have time as our x value, right? And distance from home as our y value. So we can kind of see what's happening each time. So he stopped at B, D, and F, right? Otherwise, the rest, A, C, and E, he's driving away from home, right? What's happening at G?
He drove straight home.
He's going home, right? He's closer to home again. So just being able to understand what graphs mean. So where do we see the drive straight home? We already talked about it. G. He's going straight home. Where did he stop to buy gas?
B.
B. Good. Everyone following along? Makes sense? If you're confused, let me know. We'll try to go over it a different way. Where did he start his drive? A. And where do we see him stopping for lunch?
F.
F. See how that's longer time too? It took him longer to eat lunch than to get gas or buy fruit, right? The fruit and the gas is about the same amount of time. Must have just been a short stop. But he took a long lunch. Looks like about 2-hour lunch, huh? Lucky duck. Because here's the time, right? From here to here, this was an 8-hour day. And his lunch started like a little past the 3-hour mark and went almost to the 6th.
No, I mean like how you got G for going straight home or going stopping for gas or.
Okay, so then we talked about continuous graphs and discrete, right? Continuous go on and discrete have distinct points. So we're going to determine from each of these situations, tell whether the graph for the situation would be a continuous graph or a discrete with just individual points. So if we have snow falling during a snowstorm,
Discrete.
it's going to be continuous, right? It's not going to dump a bunch of snow and then stop and dump a bunch. It's continuously snowing. As time's going on, the snow is changing, right? So this would be a continuous graph.
And 7 is discrete.
Yes, because salesmen selling a vacuum for $20 each, right? They can't sell parts of vacuums. So if we had the money being made and the number of vacuums being sold, you'd have discrete points. You would have 1, 20, 2, right? If I had a 1, it'd go up to a 20. 2 would go to, does that make sense to you guys? Actually, that should have been a 20, not a 10. 2 would be 40, and so on. 3 would be 60. Okay, I can't sell part of a vacuum. I couldn't ever make $25, right? So I wouldn't connect those points. Those are discrete. So do you see the difference between a continuous graph and when we need it and a discrete graph and when you're going to use a discrete graph? Okay. Now we're going to look at graphs and we're going to determine the domain and range of the graphs. So first of all, what type of graph is graph 8? Is it continuous or discrete?
Discrete.
It is a discrete graph. I want to just identify these quick too so we can practice that. What about number 9?
Discrete.
It's also discrete. What kind of graph is number 10? Continuous. Now your domain and range are going to be different too, whether you have a continuous graph or a discrete. Okay? So on a discrete, we can see our ordered pairs, right? This point is at 1, 1, correct? Where's my second point?
2,
2, 2. What about my next point?
3,
3, 3,
And then 4, 4, and the last one is at?
5, 5.
So now my domain and range, for my domain, I write down all of my x values. What are my values for x in those ordered pairs?
1, 2, 3, 4, 5.
Good. And what is my range?
1, 2, 3, 4, 5.
This happens to be the same, right? All my y values are the same. 1, 2, 3, 4, 5. Okay? Now we have another discrete graph, but it's not linear. This one makes a line, right? It's easy to see. This one has numbers all over the place, right? So let's write down those ordered pairs. So on this graph, I'm going to start over here. This one is over 1, up 3. So my ordered pair is 1, 3. I'm going to do all these ones along this line. Then I have 3, 3, right? And 6, 3. And what's that last one there?
8.
8, 3. So all of my input values were changing, but what do we notice about my output value, my y value?
No, it stays the same.
They're all 3, right? It didn't go up or down, it stayed at 3. So if I go up here, this is at 2, 6, right? And then I also have 7, 6. What are my last two ordered pairs?
They're the same.
They're 4, 9, and what's the other one? 4, 9, and
5, 9.
5, 9. So now I can identify my domain and range. So my domain, I'm going to circle them. I have 1, 2, 3, 4, 5, 6, 7, 8. Do you see how I used all the values from 1 to 8? So my domain is 1, 2, 3, 4, 5, 6, 7, and 8. Questions on that? Okay, now my range are all my y values. Who could tell me what the range is?
3, 3, 3, 3, 6, 6, 9, 9.
You only have to list them one time. So what is my range?
3,
3,
6,
6,
9.
and 9. Perfect. Awesome. I'm so bad at drawing these little squiggly marks. That's just showing my set. There we go. That's better. Now, the continuous gets a little bit tricky, okay? So my domain, where do I start at with my x values?
0, 0.
I start at 0, right? And where do I end?
At 11.
No, for my x.
5.
So my domain,
0 to 5.
I'm going to use t for time and d for distance. Are you guys good on that? So my domain is going to be greater, t has to be greater than 0, but less than what? What's the greatest I got? 5. Now, why didn't I just put 0, 1, 2, 3, 4, 5?
Because there's no point.
Right, and it's everything in between there. It could be 1.1, 1.2, 1.967893. So you have to include all the data between 0 and 5, and that's how you write it. You could have defined your time as anything. Your x, you could have even called this x if you wanted. You could have said x has to be greater than or equal to 0, but less than or equal to 5. Okay? To the left? Oh, sorry.
This is a short.
It is short. Short and sweet. So now looking back at that, what is our range? So that, you could say y, or I could use d for distance, right?
0
So it can be greater than or equal to 0, right? And also,
to
how high did it go to the top here, right? So it has to be less than or equal to, did it go to 10?
10 or 11.
Did it end at 11?
Go.
So less than or equal to 11. Do you guys remember we wrote these inequalities? See why we were doing it? There was an application for it. Okay? Any questions on this?
No.
I forgot to add this ordered pair here, the 0, 0. So this would have 0 for your domain and your range also. So please go back and add that to your notes. I missed this point here. There was a point at the origin. So x could be 0, so your domain is 0, and y could be 0.